We're going to look today at simultaneous equations with a graphical method. You'll be very familiar by this point with how to solve a simultaneous equation algebraically. However, they do like to throw in occasional questions where you have to use a graph. It's a very useful thing to understand. The first thing we're going to look at is how do we actually draw straight lines. A little bit of a reminder. So there is two forms you can have. You can have y equals mx plus c and ax plus by equals c. First one we're going to do is we're going to deal with y equals mx plus c by plotting y equals 3x plus 2. There's two methods. You can use the gradient intercept method or the table of values. Either one will give you the same answer. Use whichever one you're most comfortable with. I'm going to use the table of values purely because it's easier at this point. You've got to pick two values of x. I mean, I use 0 and 1 just because they're nice and low. They're not going to be on the graph. Use what you want. It doesn't make the slightest bit of difference. So if I draw myself a little table of values, x is 0 and 1, I need to know what the values of y are. So the first thing we're going to do is we're going to substitute those values of x into my equation y equals 3x plus 2 to get our values of y. If I put in 0, substitute 3 times 0 plus 2, that will give me 2. If I substitute 1 in, I get 3 times 1 plus 2, which will give me 5. And now to find coordinates. If I've got x is 0 and y is 2, that gives me 0, 2. And consequently, 1 and 5 give me 1, 5. Now I'm going to plot those on a graph. The reason I have put crosses rather than dots is it's very simple then to see where your answer is. If you put a dot, you draw over it, it doesn't show your method as clearly. It doesn't make a difference, you don't gain marks for it, but I just find it easier. Now I'm going to draw a line. Let's look now at our next one. So we've got ax plus by equals c. Notice here the x and the y are on the same side. If you can notice that, you'll know it's this method you need to use. We're going to use the cover-up method. So we're going to draw 4x plus 3y equals 12. Our first step is I cover up the 4x. The only way that can be true, if you'd want it to be not there, is if x is 0, because 4 times 0 is obviously 0. This leaves me with 3y equals 12, which says that y is 4. So my first point is 0, 4. I'm going to do the same again with y. I'm going to cover up y. Y has to be 0, leaving me with 4x equals 12, therefore x is 3. That gives me the point 3, 0. I'm going to plot these and join them up. Notice how I've got a straight line. If we want to solve equations simultaneously, they have to be the same points of x and y that work for both equations, which means we're going to draw them. Where the two lines cross, that will be our solution. So, the first one. Use a graph, find the solutions to y equals 2x plus 1 and 7x plus 3y equals 42. So for my y equals 2x plus 1, as before, I'm going to use a table of values, which will give me this. It'll give me the 2 points 0, 1 and 1, 3. For 7x plus 3y is 42. I'm going to use my cover-up method as I talked about, which will give me 0, 14 if x is 0 and 6, 0 if y is 0. I'm drawing them on the lines. Notice a couple of things. I've drawn them in different colours. Don't do that in your exam. If you draw them in different colours, you'll probably have to draw them in pen, and then you're probably going to get them wrong. And if you get them wrong, you can't rub them out. Do them in pencil. Just make sure that you do them neatly. You'll also notice that I have labelled each graph. This is purely so it shows your understanding. We'll notice that these two graphs cross at one point. It is impossible for straight lines to cross more than once. They can cross never, but only if they're parallel. You'll never get one of those questions. Sometimes though, they do throw these questions in with quadratics. We'll deal with that in a different video. Looking at this, we can see that our intersection point occurs at x is 3, y is 7. There are our solutions. To look at another one. We've got here, use a graph, find the solution to y equals 4x plus 1 and 2y minus 4x is 2. If I draw y equals 4x plus 1, it's y equals, I'm going to use the table of values again, which will give me 0 minus 1 and 1, 3. For 2y minus 4x is 2, as before, I'm going to use the cover-up method. Now if I cover up x, notice here we've got a minus. The minus has to do with the 4x. So if we cover up the 4x, that is, minus is not there. So we're left with just 2y equals 2, therefore y is 1. Now if I cover up y, I'm not covering up the negative. I've got minus 4x equals 2, so therefore x equals minus 0.5. So I've got minus 1.5, 0 as my second solution. If I plot these on my graph, I get this. Once again, as before, we can look at this and say that our solutions lie at x equals 1 and y equals 3.